So we're looking at page 20 of your unit handout. This is the final lesson in this unit. There's nothing really new we're learning. We're just, I suppose, expanding our horizons in terms of types of questions and complexity of questions. So we're going to continue to work with composite functions, but we're also going to be combining compositions with operations. Compositions is what we've just been talking about. Operations are things like adding functions, subtracting functions, multiplying them, and dividing them. And we're going to, as I said, expand our horizons here a little bit. We're not going to be limiting ourselves to just two functions. So there's nothing new here. It's just a lot of questions. H of x equals f of g of x. And this is a weird question, but I've seen this kind of thing on a diploma exam before. This right here is f of g of x. So that thing that I'm indicating is the result of putting one function in for x in a second function. And I will tell you right now that very few people get this without being shown it. But I'm curious, does anybody know what two functions I could create so that the input of the second function yields, let me repeat that. We're looking for two functions where if I feed one of the functions into the second function, I get that. You know?
Yeah. X plus 2 for g.
Okay. X plus 2 for g of x.
X squared plus x plus 2.
Excellent. And if you see that immediately, like a couple of you did, I think what you're kind of doing, probably, I don't know. I wish I could get inside of students' minds just for a short period of time to understand how you think. It would be valuable as a teacher, but I can't. I think what you're looking at there is you're seeing that it's something squared plus the same thing plus 3. So that's the input, and it would be the output of g of x. Don't forget that f of g of x means this goes into f. And as I said, there's no procedure here. This is something you just look at and you see. And I think the likelihood of you seeing this on an exam is pretty thin, slim, but it's still there. This one. Can we come up with two functions so if I feed one function in for x in the second function, I get this function, which is the root of 3x plus 1. How many of you see what the answer to this is, or what an answer to this is, and you didn't see it the first time in A? Patrick.
Square root x for f of x.
Okay, f of x is root x. Excellent.
And then g of x is just 3x plus 1.
Excellent. G of x is 3x plus 1. So the idea here is that g of x goes in for x in f of x. If I were to take this whole thing here and put it right there, I would get the function. Now, a number of years ago, I had a student put up their hand and say, could I say this? Could I say, and I don't think they were trying to be clever or witty. I think they were being serious. At first I thought, oh, they were just kind of making a joke. And then I realized, no, it's a good question. Could I say f of x is the square root of 3x plus 1, and g of x is x? And the answer to the question is yes, you can say that, right? You could say that with any function. I could go back to this, and I could say f of x is that entire function, and g of x is simply x. It's a really clever, and I don't mean that as an insult to the student, it's a very clever way of getting an answer to the question. But I hope you understand it's not what we're driving at in this kind of question. Okay. Let's take a look at number 2. When a rock is dropped in water at a lake, a circular wave spreads out. The radius of the circle is given by 0.25 t, where t is the time in seconds. So that is r of t, which simply means the radius depends on the time. From a physics standpoint or a science standpoint, the reason why the radius is 0.25 t is the wave is traveling at 0.25 meters per second. So every second that goes by from the center where the rock hits the water to the edge of the ripple, which is the radius of the circle, every second that goes by, the radius grows by 0.25 meters. And I just want you to understand something here, that the time is used to find the radius. Just in general, right? If you knew the time, you could find the radius. It says the area of a circular ripple is pi r squared. A of r equals pi r squared. All that is saying is if you know the radius, you can determine the area. Are you with me? So if I told you the time was 3 seconds and I said, what's the area? If I said this, the time is 3 seconds, what's the area? You can find the radius first using the first formula and then use that radius to find the area. And let's do that. I'm going to put 3 in for t, and you can confirm you get 0.75. So the radius is 0.75 meters. And then the area is 0.75 squared times pi. .75 is 3/4. When I square 3/4, I get 9/16. You can work it out in decimal form. Whatever 9/16 times pi is, that's the area in square meters. So in earlier teachings, sometimes I would say to you, you know what, we don't really need to worry about the function notation. But the function notation is important. It tells you what the variable is that's going in. But if you are at all confused by the function notation, you could kind of ignore them. What does it mean to say a of r of t? A of r of t is going to be a formula that you can put t in and get a without calculating r in the middle. Okay. If I go back and look at, I'm going to look at this example and not this student's idea. If I told you that x was 8, and I said, what is h of x? Then you could put 8 right in here, couldn't you? That's what you would do. Yes? Okay, what do you get for h of x when you put 8 in there? 5, right? 3 times 8 is 24, plus 1 is 25, square root of 25 is 5. But what we could have done is put 8 in here and found g of 8, which is 25, whoops, and then fed it in here to get root 25. Are you with me? So in this question, what's happening is we have the two equations to begin with, but we don't want to do it in 2 stages. We just want a single formula that I can put t in to get a. And a of r of t simply means put r of t in as an input in a. So what's going to happen is this is going to go there. That's all. It's an algebraic substitution. So we are going to have a of r of t equals pi times the radius squared, but the radius is 0.25 times the time squared. 0.25 is 1/4. So we have pi times 1/4 t quantity squared. When I square 1/4, I get 1/16. So this is a of r of t. And again, it's just the formula that allows us to put t in and calculate a. diploma exams aren't particularly interested in these types of applications, but you never know when one might pop up. All right, now we just have a whole slew of problems. This has nothing to do with compositions. You're given three functions at the top of your page, and you're asked to find k of x if k of x is f plus g times h, quantity of x. Well, order of operations says we multiply before we add, so what k of x is equal to is f of x plus g of x times h of x. The first level in being successful in this question is understanding that's what it's asking you to do. The second level is actually doing it. So we're simply going to put in the functions. K of x is 3x minus 2 plus the product of x squared minus 4 and x over x minus 2. Now, we want to simplify things wherever possible. This product is a product of rational expressions. Yes, it's true we multiply across the top and multiply across the bottom when we're dealing with multiplying fractions. But we want to simplify the fraction. And to simplify a rational expression, you factor and cancel. So multiplying that across the top is going in the wrong direction. We need to factor things completely. So now what I have is k of x is equal to the 3x minus 2 plus, I can put this whole thing as a single fraction. I have x plus 2, x minus 2, and then I have times x. I'm going under the assumption here you know that x squared minus 4 is a difference of squares. Divided by x minus 2. I mean, there is a non-permissible value we can take note of here, that x is not equal to 2. But the bigger picture is those two factors cancel. So we are left with k of x equals 3x minus 2 plus x plus 2 times x. Now we can multiply it out and pack it together. It's going to be a quadratic polynomial. Let's see, I have 3x minus 2 plus x squared plus 2x. Might as well put that 3x and 2x together and get k of x is x squared plus 5x minus 2. And by the way, everyone, x is not equal to 2. We've learned enough in various different units over the past couple of years anyway, that non-permissible values never die. They just hang around. No matter what you do to the expression, non-permissible values are non-permissible values. Any questions with that one? All right. What if k of x is h over f times g? Well, that means h of x over f of x times g of x. And really what the first couple of questions so far are dealing with is your ability to work with rational expressions. Just like when we did trigonometry, we had all those rational expressions with trig. So I'm going to start putting things in. K of x is x over x minus 2 over the product of f and g, which is 3x minus 2, and x squared minus 4. I had a really good conversation with my Math 20s yesterday. We were learning about dividing rational expressions. And when we learn about dividing rational expressions, I teach people, well, you have to multiply by the reciprocal. But by the time we get here, and I told them this, I said, by the time you get to Math 30, you're not going to do that. What you're going to do in a case like this, even though you are dividing, rational expressions is you're simply going to say, I'm going to multiply the top and the bottom by x minus 2 to eliminate that denominator of x minus 2. So what do we get? We get, so far, k of x equals x on the top, and on the bottom we have 3x minus 2. We have the x squared minus 4. We might as well factor that because these types of expressions, which are called rational expressions, need to be factored. And then we have another x minus 2. Nothing cancels. The only factor we have on the top is x. I don't have a factor of x on the top. So we can write our final answer in factored form as x over 3x minus 2, x plus 2, x minus 2 squared. And, this could be a multiple choice question. It could be maybe a 2-mark written response question. I could make it into a numerical response question by putting A's, B's, and C's on those 3's and 2's in different places. But that's the answer to that question. Any questions with B? Reading left to right, it's h of g of f of x. And if you think about what I've written here and you look at what I've taught you before, what this basically means is f of x goes into g and that whole thing goes into h. And that's what this is showing. F of x is going into g, the whole thing is going into h. So there's a lot of ways that you can think this through, but because there's 3 kind of layers to this, it's kind of confusing. I would personally figure out, and I'm going to not use the colors here, what is g of f of x? Let's figure out what that is first. Then we can worry about going further. Well, g of x is x squared minus 4. G of f of x means I'm going to take this and put it in there. It's going to become 3x minus 2 quantity squared minus 4. And we need to simplify that. We can simplify it later if you like, but I think it's better to simplify it now. So I'm putting f of x into g of x. I have to FOIL this out and get 9x squared minus 6x minus 6x plus 4 minus 4. Can you confirm that when you take 3x minus 2 times 3x minus 2, that's what you get? Good. So the 4's cancel, and I'm left with 9x squared minus 12x. And that is this whole thing. That's g of f of x. And that means that this whole thing needs to go in here and here in h, because it's h of that whole thing. So I am going to get for k of x, I'm going to get the 9x squared minus 12x over 9x squared minus 12x minus 2. Could we potentially look at factoring things? Well, the top factors. I don't know that the bottom factors. It's not worth our time. That's not the point of this example. Any questions with C? It requires slowing down, and at the beginning of this example, I wasn't going slow enough. I made those couple of little mistakes. You want to make sure that you go slow enough that you minimize your mistakes. H of g of x. So what does this mean? This means that g of x is going to go into g of x, and whatever comes out is going to go into h of x. I'm just showing you visually a different way to look at this. Right. Algebraically, the notation is k of x is h of g of x. So we need to take this and put it in for x here, and whatever we get for that thing, we're going to put in for x here. I'm going to figure out again that middle part first, g of x. Well, g of x is the input squared minus 4, but the input is g of x, which is x squared minus 4. Let's simplify this. I need to take x squared minus 4 times x squared minus 4, and then subtract 4. We have learned in Math 3-1 about polynomial functions of degrees higher than 2. You should be able to handle this. Foiling this out, I get x to the 4 minus 4x squared minus 4x squared plus 16 minus 4, which is giving me x to the 4 minus 8x squared plus 12. That is g of x. G of x is this. Which means, and I'm going to write this out, I don't know that you need to, but k of x is h of that. It means we have to put that in for x and h. And h is just peeking out of the top of the screen there. It's x, or the input, which is x to the 4 minus 8x squared plus 12, over the input minus 2. I really so much just want to write plus 10 here. But I'm going to put plus 12 and then minus 2. And I'm not going to spend time rewriting it, but you, of course, would rewrite it with plus 10 on the bottom instead of writing 12 minus 2. Is this potentially something that could be simplified? Yes, but it wouldn't be something that you would encounter on an exam to simplify. It would be just a little bit too much in this single question. Back to numbers. Numbers are simpler. So we've kind of climbed the hill. We're at the top of the hill. We're starting to come down in the lesson. Okay. What is f plus g plus h of negative 2? What does that mean? It means f of negative 2 plus g of negative 2 plus h of negative 2. This is just, I don't want to say piddly little details, but it's choppy little math work here. We need to put negative 2 in for x and f, figure out what we get. We need to put negative 2 in for x and g, figure out what we're going to get. We need to put negative 2 in for x and h, figure out what we get, and add those three things together. If this were a written response, you would be showing your work. However, well, you know what, I'll show it. 3 times negative 2 plus 4. Okay? That's f of negative 2. G of negative 2 is negative 2 squared minus 9. H of negative 2 is negative 2 over negative 2 plus 3. I hope you're catching my drift here, that all I am doing is everywhere there is an x in those respective functions, I'm putting negative 2. So we can work those three things out. I believe you get negative 2 here. You keep me honest, make sure you're on top of this. Over here you get negative 5. 4 minus 9. And here you get negative 2 because the bottom of this fraction is 1. So I'm getting negative 9. Any questions with 4a? Yep.
Could you do it the algebraic way and then just plug the number in again? Or does it
You certainly could do the algebraic way. And what Ariana is saying is rather than putting the 2 in everywhere, could we add the 3 functions together, simplify that result, and then put negative 2 in? Certainly. Or could you just add the 3 functions together and not even simplify it and then change all the x's to negative 2? Without a doubt. Definitely. Because we're adding the functions, if we were dividing or if there were some other potential where they would simplify before we put the negative 2 in, it's a very wise move. Nothing really simplifies here. In fact, everybody, and I know you see this, but if I add the functions together algebraically first, if I wanted to simplify them, I'd be looking at common denominators, which would be a real bummer, right? It'd slow me down considerably. But you could, yeah. G of h over f plus g of 2. What does that mean? It means g of h of 2 over f of 2 plus g of 2. This is not a difficult question. There's just more pieces to it. For example, f of 2, I'm going to put 2 up here and get 10. Can everybody agree that f of 2 will give you 10? With the condition, of course, you'd show your work on a diploma exam or a written response problem. What about g of 2? I need to know g of 2 as well. I hope you would agree that g of 2 is negative 5. Okay. So that means in this expression on the bottom I have 10 plus negative 5. On the top I have g of h of 2. That means I take 2 and feed it through h, and take that result, whatever it is, and feed it through g. So when I put 2 in here, I get 2/5. Now I need to take that, square 2/5 and subtract 9. I'll let you do that on your calculator while I run it through my head. Negative 221/25. I don't know. I'm asking you. Yes? Negative 221/25. So that's what comes out. Sooner or later, you can just say, look, I'm getting tired of showing all my work. Let's use the calculator. What you're going to get here is you have negative 221 over 25. You're going to divide by 5 because that's what's on the bottom. What you're going to get is negative 221 over 125, I think. And I'm seeing some nods, so we're on track. G of f of h of 3. Okay, this one is actually a little more straightforward because it's just compositions. It's not compositions and sums or quotients and compositions. This gets fed through h. Whatever happens coming out of h gets fed through f. Whatever that is gets fed through g, and that gives us our answer. So 3 through h. I'm going to put a 3 here and here. You're going to do the same thing, and you're going to confirm, or tell me I'm wrong, that when you put 3 in for x in h, you get 1/2. Okay? Now you're going to put 1/2 in here. So you're going to take 3 times 1/2, and you're going to add 4, and I believe you're going to get 11 over 2. Well, I could be mistaken. No, I want to say 11 over 2. 11 over 2. So 11 over 2 comes out. I'm not showing a lot of work right now because I'm just in teaching mode, and I think you're just in learning mode, okay? We're not in the details and the procedures here in terms of writing exams. Now I need to put 11 halves in here, so I need to square 11 over 2 and subtract 9. Is it 85 over 4, or am I mistaken? It is 85 over 4. So the answer is 85 quarters. Good little numerical response question. You know, what do you get in decimal form? What is that, 21.25? So it might say to the nearest tenth, you'd go 21.3. Oh boy, back to mixing up operations and compositions. What this means is f of g of negative 1 over h of negative 1 multiplied by g of negative 1. So you have three pieces to figure out. I'm going to give everybody a minute here to find out what this is. F of g of negative 1. I'm getting negative 20. When I put the negative 1 through g, I get negative 8. When I put that negative 8 through f, I get negative 20. So on the top of this expression, we have negative 20. On the bottom, we're going to have h of negative 1. So you're going to put negative 1 in for x here and get negative 1/2, I believe. Good. Multiplied by, I'm going to put negative 1 in here. Well, we already know what that is. That's negative 8. On the bottom, the negatives cancel, and 8 divided by 2 is 4. So I have negative 20 over 4. This should work out to negative 5, but just, my brain slips a gear from time to time. Just make sure that you can live with that. That's good. Okay. Okay, so now we have graphs. What is f minus g of negative 5? Well, that means f of negative 5 minus g of negative 5. What is f of negative 5? Well, f of negative 5 means when you look at negative 5 and you look at the function f, what comes out when you put negative 5 in for x? And the answer is 4 comes out. This is 4. Minus, what is g of negative 5? Well, g of negative 5, you look at x equals negative 5 going in, and what comes out of g is 6. So this is negative 2. I'm hoping that many of you can answer B without doing much work. The only difference in B is that you're subtracting in the opposite order. So you're going to have 6 minus 4. What is f times g of 3? What that means is f of 3 times g of 3. F of 3 means you go over to 3 and you look at the y coordinate coming out of f, which is 2. G of 3 means you look at x equals 3 but now you're looking at G. What comes out is also 2. So this gives us 4. Any questions with A or B or C? Right? G of f of 3. So this means 3 gets run through F. Whatever comes out gets run through G, and that gives us the answer. Keep in mind this is X. I'll start with Y. This is Y on F. It's the output of F. But because it's going into G, it's X on G. So we look at 3 going in, and the output on F is 2. Now we put 2 in, but we're looking at the output on G. So when I look at 2 going in on G, the output is 1. So the answer is 1. Well, what about the opposite way around? That was G of f of 3. Now we're going to go f of G of 3. Again, the 3 goes into G first. Then it goes into F to get our answer. So 3 goes in. What comes out of G? Well, G is the absolute value one, but 2 comes out. So this is a 2. 2 now goes in. But we're going to read the output on F, and it is approximately, I would say, 2.3 or 2.4. Take your pick. I've seen numerical response questions like this where they actually ask you, approximately to the nearest tenth, what is it? And they won't accept 2.2 and they won't accept 2.5, but they'll accept 2.3 or 2.4. Okay? After a while, you get into the swing of things here, and it's pretty easy, but it's easy to make a mistake. This means we're going to feed 3 through F. Whatever we get out, we're going to feed through G. Whatever we get out, we're going to feed through F to get our answer. I'm going to give everybody a minute to get the answer. And put up your hand when you have it. Just put up your hand and put it down again. I hope those of you that have it, and everybody else as well, you understand that if this isn't written down, it's pretty confusing as to what you need to do. Like when I wrote this down and then I did the problem, I looked back at this thing that I wrote at least twice. Do you have it, Brody? What do you say?
I put 2.8.
I would say 2.8 as well. If you went 2.7, that's fine. But just following the flow chart there, 3 goes in, and out of F comes 2. 2 goes in, out of G comes 1. And 1 goes into F. What comes out of F is, 2.7, 2.8. Take your pick. Did you say 2.8? Okay. We'll go with 2.8. But if you said 2.7, I think that would be fine. I don't think 2.6 BFE. I don't think 2.9 would be good. Okay, I'll give you a second to do this one. I'm not going to write the flow chart. I will warn you, if you don't write the flow chart, it's pretty easy to make a mistake. At least for me, anyway. I don't know. We've got a disagreement here. I'm going to double check. I think it's 1. Now, admittedly, I did it without the flow chart. And a couple of people indicated to me you think it's 0. Let me do the flow chart. This says 4 goes in through F, then the result goes through G, then the result goes through G another time, and this is our answer. So when I put 4 into F, F is the curve. I put 4 in, 1 comes out. 1 has to go into G. So here's 1. G is the absolute value function, so what comes out is 0. 0 now has to go in for G. 0 is an x-coordinate of 0, which is here. What comes out is 1. It is so easy to make a mistake. And I will tell you right now, I've taught this lesson many times, and very often I will make a mistake here. I'll say something like 0, and then I'll use that as an opportunity to say, you know what I didn't do? I didn't draw the flow chart. Make sure you look at the flow chart. Determine the domain of each function. Well, there's a common domain. I'm taking this opportunity to review some things. A common domain is x is less than or equal to 4. Is that the domain of f over g? I'll give you a hint. No, it's not. Why is that common domain not the domain of f over g? Thomas? X can't equal 1. Excellent. Why, Thomas, can x not equal 1? Right. At this point, g of x is 0, so you would be dividing by 0. If I said to you, what is the domain of this? G over f. You would start with x is greater than or equal. Geez, did I write greater than before? No, I didn't. You would start with x is less than or equal to 4. Is that the domain of g over f? Yes. There is no place in that domain where f of x is 0. So you're not going to be dividing by 0 anywhere. Difference? Common domain. You don't need to worry about common domain, oh, but let's exclude something else when you're subtracting, because you can always subtract if the two functions exist. Number 7. And this rounds things out. You're given a bunch of functions at the top. It doesn't matter what they are. When we get to the function we need to use, we'll look at it. This says g of f of a is 98, which means a, some number, goes into f, the result goes into g, and you get 98. We got to work backwards here to find out what A is. And if you don't do that flow chart or that flow diagram, whatever you want to call it, it's difficult. Don't forget that this is a y coordinate on G, and this is the x coordinate on G. I'm focusing my attention right now, everybody, on this, on just the second stage of this. And hopefully it will pop up. There it is. That's all I'm focusing on right now. So when we look at g of x is x squared minus 2, which means 98 has to be equal to x squared minus 2, which means x squared has to equal 100. So what is x equal to?
I'm doing both functions already. So if
But I'm just asking right now with this equation, x squared equals 100, what is x?
10.
10? Anything else? Plus or minus, that's right, Ashley. Plus or minus 10. We're going to have two sets of answers here. We're going to have 10 or negative 10 going in to give us 98, which means A has two possible answers. Now, when I look at this negative 10, I know I said this was a y coordinate on G, sorry, an x coordinate on G. It's a y coordinate on F as well. It's coming out of F, which means what we're after is an x coordinate on F. But we have two equations to solve. F is 2x plus 4, which means 10 equals 2x plus 4, or negative 10 equals 2x plus 4. There's two answers here. If I solve this one, I'm going to get x equals 3, I think. Subtract 4 and divide by 2. If I solve this one, I'm going to get x equals negative 7. I think. Okay. So A is 3 or negative 7. And I won't, we're running a little behind schedule here, I apologize. I won't put them in, but if you put them into F and then put the result into G, you'll get that 98. J of H of A is 0. That means we put some number in for H, then put it in for J, and you get 0. So 0 comes out of J. That means 0 equals log base 3 of x, which means x is 3 to the 0, which is 1. Oh, 1 has to go into J to give us nothing. But that means 1 comes out of H. Well, we're back to trigonometry. Where is sine of x equal to 1? At the top of the unit circle. So what we have here is A is equal to pi over 2, plus, of course, or obligatory multiples of 2 pi. Where n is an element of the integer number set. And of course, it's pi over 2 because at pi over 2 the y coordinate on the unit circle is 1 and sine is the y coordinate. One last one. K of J of A equals 8. A goes through J. I don't know how the average person would be able to wrap their head around this stuff without drawing these diagrams. I really don't. I mean, I think they just make life so much easier. So A goes into J, which then goes into K, and we get 8. 8 comes out of K, which means that's the statement connecting the input and output of K. Well, x is 3. I don't think you need logarithms or anything to see that. 2 to the 3 is 8. That comes out of J, which means, so what you end up with is x equals 27, which means A is 27. Whole bunch of different questions that you can try here. There are some more complicated, some more easy, some are just basically you're looking at graphs to pull the information off. Okay, so get to work on that and I'll come around and I'll give you a hand.